Good morning everyone. I am Aastha and today I'll be presenting on the topic Hadoop, its architecture, components and real world use cases. Hadoop is one of the most important technologies in the field of big data, and by the end of this session you will clearly understand how it will works and why it's so widely used. Now let us first understand what is big data. Let's begin by understanding big data. Big data refers to extremely large data sets that cannot be processed using traditional systems. It is defined by the 5 V's. Like basically big data have 5 V's. To understand it better, we studied further. The 5 V's are volume, velocity, variety, veracity and value. By volume, it means massive amount of data being generated. By velocity, how fast the data is produced and processed. Variety, different types of data, text, images, videos, logs, etc. Veracity, uncertainty and quality of data. Value, the meaningful insights we extract. These 5 V's are exactly why organizations require new technologies like Hadoop. Now we see the introduction to Hadoop, that is the game changer of big data. Hadoop is the game changer of big data. Hadoop emerged as a game changer in the world of big data. It is an open source framework developed by Apache to store and process used data sets efficiently. Earlier, organizations struggled with three main issues. First, data was growing too fast. Second, traditional systems were very expensive. Third, processing large data was slow. Hadoop solved all these challenges through distributed storage and parallel processing. Now we see what is Hadoop and why we use Hadoop. So why exactly is Hadoop? What exactly is Hadoop? It is a framework that uses clusters of commodity hardware to store and process massive amount of data. Hadoop is chosen because it's scalable, it's cost effective, it's fault tolerant, and it can handle any type of data. That made Hadoop the foundation of big data analytics for many years. Now we see Hadoop ecosystem, complete big data stack. Hadoop is not a single tool, it is an entire ecosystem. It includes HDFS for storage, Yarn for resource management, MapReduce for processing, along with high-level tools like Hive, Pig, HBase, SCube, Flume, Zookeeper, Oozie, and many more. Together, these form a complete end-to-end big data stack. Now we see HDFS as scalable and fault tolerant storage. HDFS stands for Hadoop Distributed File System. It is designed to store very large files across multiple machines in a cluster. Key features include scalability, fault tolerance, high throughput, cost effective, etc. Scalability means store petabytes of data. Fault tolerance means data is automatically replicated. High throughput means optimized for large data sets. Cost effective means use commodity hardware. This makes HDFS the backbone of Hadoop. Now we see HDFS architecture, big deep dive. This slide explains how HDFS internally works. It has two main components, name node and data node. Name node means the master stores metadata, manages the file system. Data nodes means the workers stores actual data blocks. When you upload a file, it's split into blocks, replicated and distributed across data nodes. Even if a node fails, HDFS recovers data from replicas. That's how fault tolerance is achieved. Now we see Yarn, the resource management. Yarn stands for yet another resource negotiator. While HDFS stores data, Yarn manages system, resources and schedule tasks. It has two major components, resource manager that decides how resources is allocated, and node manager that sees, monitors, and manages each node. Yarn ensures that all jobs running in the cluster get proper resources without conflict. Now we see MapReduce distributed processing. MapReduce is Hadoop's original data processing model. It processes data in two phases, that is map phase and reduce phase. Map phase processes and filters input into key value pairs. Reduce phase aggregates and summarizes the output. Parallel processing is its biggest strength. A classic example is the word count problem. The map phase counts occurrences of word, and reduce combines the counts. Now we see MapReduce data flow. This slide shows the complete life cycle of a MapReduce program, that is input, then mapper, then shuffle and sort, then reducer, then final output. The shuffle phase is critical because it groups data based on keys. This entire workflow runs across multiple machines simultaneously, making it highly efficient for large data sets. Now we see Hadoop's ecosystem tools and technologies. Hadoop's ecosystem expands through many powerful tools like Hive, Pig, HBase, SQ, Flume, and Zookeeper. Hive is for SQL like querying, Pig is for data transformation scripts, HBase is NoSQL database, Scoop is imports and exports data between Hadoop and RDBMS, Flume collects and sends log data, Zookeeper coordination service. This ecosystem enables Hadoop to support storage, processing, data movement, analytics, and coordination. Now we see Hadoop versus traditional system. Traditional system scales vertically by upgrading the system machine. Hadoop scales horizontally by adding more inexpensive machines compared to traditional systems. Hadoop is cheaper, more scalable, more fault tolerant, capable of processing unstructured data. This is why Hadoop quickly became the preferred choice for large scale data workloads. Comparison points can be data volume, processing cost, schema, and real time. Traditional system, that is RDBMS and Hadoop. We see data volume in traditional system is GB scale limited by server capacity, and in Hadoop it's PB scale distributed storage. While processing in traditional system is centralized processing, single server, and in Hadoop it's distributed processing, that is cluster of nodes. Cost of traditional system is expensive, and cost of Hadoop is commodity hardware, that is cost effective. Schema of traditional system is fixed schema, that is rigid structure, while Hadoop has flexible schema on read. Real time, yes, traditional systems are real time and has low latency transactions, while Hadoop has batch processing, that is high throughput. Now we see layer architecture. Hadoop's entire workflow can be summarized into three layers: storage layer, that is HDFS, processing layer, that is MapReduce, and resource management layer, that is Yarn. These layers work together seamlessly to handle big data from end to end. Now we see real world applications. Hadoop is used across almost every sector: finance, e-commerce, healthcare, telecom, social media, and etc. Finance for fraud detection, e-commerce for product recommendation, healthcare for patient analytics, telecom for network monitoring, social media for user behavior analysis. Any industry that deals with huge data volumes benefits from Hadoop. industry leaders using Hadoop. Many global companies rely on Hadoop for data processing. Some major names include Facebook, Amazon, Netflix, Spotify, LinkedIn, and Yahoo. These companies generate terabytes to petabytes of data daily, and Hadoop helps them manage it efficiently. Now we see key advantages of Hadoop. To conclude the technical part, these are the major advantages of Hadoop, that is cost effective storage, high scalable architecture, fault tolerance through applications, handles all data types, open source and widely adopted. These trends made Hadoop the foundation of big data era. First, cost effective, utilizes commodity hardware instead of expensive specialized server, significantly reducing infrastructure cost while maintaining performance. High fault tolerance, automatically handles node failures with data replication and recovery mechanism, ensuring continuous operation without data loss. Horizontal scaling, easily scales by adding more nodes to the cluster, allowing linear growth in storage and processing capacity as needs increases. Flexibility, processing both structured and unstructured data types including text, images, videos and sensor data without requiring predefined schemas. Now we see limitations of Hadoop there, but Hadoop also has limitations. MapReduce has high latency that is not suitable for real-time use. Cluster management can be complex. These drawbacks open the path for newer technologies like Apache Spark. This slide compares Hadoop versus Spark. Hadoop MapReduce is batch-based, whereas Spark provides in-memory processing, making it much faster. However, Spark often still uses Hadoop's HDFS for storage, so the two technologies complement each other instead of competing directly. We see future of Hadoop. Although MapReduce is declining, Hadoop is a framework is still relevant. Its ecosystem HDFS, Yarn, Hive, HBase is widely used in cloud platforms like AWS, EMR and Azure HD Inside. So Hadoop will continue evolving as part of hybrid and cloud big data solutions. Conclusion. To conclude, Hadoop is an extremely powerful ecosystem designed to store and process massive datasets efficiently. It introduced the world to scalable distributed computing and still remains a foundation for big data systems today. That brings me to the end of the presentation. Thank you for listening. I'd be happy to answer any question you comment down. Thank you so much.